Hello, 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 hello. Matthias is out traveling, so I'm here alone today, which means I will just cheat and start with Fika. Today we're going to deal with the scariest, spookiest, and most complicated thing in programming. Well, that's what people think. It's called recursion, and it's not that complicated if you just put your mind to it. We're gonna use it to fix pagination in our web scraping thingy in our online business. This is DevTips, and I'm David. This episode is sponsored by Brilliant.org. Thank you, Brilliant. They are the website that teaches you to think like a computer scientist, which comes very, very handy today when we're gonna deal with recursion. Within their computer science fundamentals category, they have a whole set of quizzes on recursion. By doing the quizzes, by challenging yourself, you will learn and understand recursion. Use the link in the episode description, brilliant.org/devtips. If you're one of the first 200 people that sign up, you will get 20% off the annual subscription. Go there, check out recursion. Last time we went to this Find Your Perfect Match page, where we have all the partners that we want to scrape. And we built a small application that could scrape. But we only scraped the first of all these. We never got here to the paginated thingy. We were just here on the first one, but we can click to the second page. And here we get more partners. We want all of the partners. The naive thinking is to just figure out what is the system. Let's check it out here. If we go to the second page, the link says with a query parameter page equals 2. And if we go to the third page, that is page equals 3. But right now we're just on the nothing page. But if we check out, we end with this partner here, Isobar. The first partner is Precis Digital. And then if we add question mark page equals 1, is Precis Digital in the start and Isobar here in the end. So we see that it follows this pattern. We can just add whatever page and then we will find that page. The naive way of doing this is to simply get the list of how many pages are there and just fetch them. So first we fetch page equals 1 and then we fetch page equals 2 and then page equals 3. We should be able to just write for page equals 1, start at the first page, and then while pages is less or equal to the number of pages, we just increment the page and go to the next page. And then we could just do and then we can just let the URL be whatever page we want to fetch. So it will be page 1, page 2, page 3. Easy, right? Thing is, here on this page, we don't know how many pages there are. We don't know how many number of pages there are. So we don't know when the loop should end. Because if I go to page 2, everything's fine. There are 7 pages. And then I go to page 3, page 4, page 5. So let's go to page 5. We're here on page 5. Wait, what happened? Before it was 7 pages in total, now there are 8. What happens if we go to page 6? There are 9 pages. And what happens if we go to page 9? 12. Jeez. We don't know how many pages there are. Then this naive approach of using the number of pages and then just looping through how many pages there are and scrape on each page, that won't work. Because we don't know the final number of pages. And this is the perfect example for using recursion. So recursion basically says that we start at the first page. We start at page 1. We fetch all these. Blah, 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 blah. We scrape all these. When we've done that, we go to page 2. and scrape all these. And then we go to page 3 and keep on scraping. And for each page, we're building up the array of the results. So we basically say that the first page, you should take all the results and then add all the results of the second page. And on the second page, we say, take all the results and add all the results from the third page. And then we say on the third page, add all the results of the next page. And just keep on doing that for infinity. And that would be a really, really bad program. Because it would just check the next page and keep on adding things to the array. Adding. But, so we need to have a final state when the recursion ends. So let's just do this. Let's find out what happens if we go to page 3000. Whoops! This is what it looks like when there are no more, when we're on like a page that doesn't exist. But we also see here that, we know how many pages there are. There are 45 pages. But we can't just say that there are 45 pages and that's it. Because we don't know if there are partners becoming added or removed. So we can't know how many items there are. Therefore, we will in the recursion have an end condition that say, once we don't find any partners, that's when we should end. And then that's a signal to the one before that this will not return any partners, to take that result with the previous result and build together with the previous result of that, and then build with the previous result of the previous. It sounds complex, but it's not very complex, and we'll just build it and you will see and sort of get it. Okay? So here's the code from the last time. This part with the partners, that was just all this bundled together. So we can remove that. We already have that. And this partners array, that is the final state that we want. So we want to somehow say that go to URL, and then once you've done all this, go to the next URL. So we want to have a function that goes to the URL, fetches all the partners, and then concatenates the partners with the partners from the next page. And then that next call to the function will check where are all the partners and get them, and then get the next page until we reach the final page where there are no partners, and then we're done. So let's just write a new function here. Const let's just call it extract partners, and it takes a URL. And we want the page, so this opens a new page, and each time we want to fetch a new page, this opens. So we should move this into here, I think. So let's just try to make the same thing, but by calling this. Take the page, move it there. The URL we can keep outside because we're going to call that one. So what we're going to do is the partners, we're going to get them by extract partners from our URL, like that. And we got the URL here, so let's take that and move that here. And this part we can just move into the function. And then we take the go to URL thing, move that into the function. And then we should return the partners. Will this work? Probably not, because this thing awaits and awaits, and to make that work we have to make this async. And then I think we have to await these partners, right? And then just to, okay, like that. Let's run this. Node scraper.js. What happens? Ha! It just worked. I did not expect it to work. I don't know how memory works here, but just if we open a page here, we should just perhaps, can we close a page? Is that what you do? Will this work? Let's just try it. Just seems to make sense that we do that. Okay, everything works. The thing with recursion is that we don't want to make we don't have to make a for loop around this. We'll just make the one call here and then return the results. Is this really formatted? No, there we go, formatted. So we get the partners here and we extract with this. So we have the partners from the current page we're crawling. So let's just write, to see what happens, let's just console log scraping and the URL that we're scraping. So we know what's happening. We scrape the URL like that. Okay, let's run it to see what's going on. We don't have to print out this right now. Okay, let's run it. Target closed warning. Unhandled. Promise. Target closed. Okay, it worked. It said what we're scraping, but what's going on here? Oh. Okay, yeah. You see, here we have to await that thing. Everything is synchronous, so we have to await this page close, I think. Yeah. Okay, so now we fetch that page. And we got the partners. So let's just see. If we start with the first page, first URL, we call it first URL. Let's see, does that work? Will it give us the things that we want? Yes. The first one was the precise digital, and then the last one was the isobar thingy. Once we've scraped this, we know that there's another page, and we want to go to that page. So we have to take from the URL. We know that there's a number 1 here, and want to extract that. So let's just make a small const next URL is the current URL, and then want to extract something, a regular expression. I've done a video on that. And we want to extract the final parts of, we know that it will end with page equals, and then a digit. But if we do this and then it ends, that's the end of the string. We know that it ends, at least in this format, and perhaps this will change and they will add other parameters, but for right now, this will work. But what happens if we put number 10 there? Then this won't match. So we have to say that it should be at least 1 digit. So we add the plus sign there. And what happens if we match this? Let's just run this in the... So if we take this and match it, what do we get? Page 10. But we just want the number, we just want the 10. So we have to make a capture group that we want to capture this part of the regular expression, of the match. So there we go. And you see that we get both digits. So if we added this, we get all the digits. And it should work with just the first one, just the one. Yes, it does. So we want to extract this part. And okay, we know that there will always be this inputted URL for our example. So we can just take the second item here. This is a 0 item and this is the 1 item, the 1. We can just pull that because this will never be undefined, because we know that it will always follow the same pattern here. Because we are actually not scraping, right now we're not scraping what it says here in the HTML. We have just figured out the system, and we will just use this as a template. We have the first URL here. We have the URL here, and then we just extract the 1th item, not the first one, that's 0, but the second one, that's number 1 in an array. That's the number. But now it's a string, remember? See here, it's a string. So we want to increment this, but if we were to just add 1, it will just add a 1. It will become 11. So parse int this. And then here is the regex. It's just that sometimes during special circumstances, it wants to know which base it is. And the base we use, the decimal thing, that's number 10. So just put that to be safe. Parse that. And we want to increment that number that we extracted. So if we extracted page 10, we want the next one to be page 11. So we will just add 1 to get page 11. And then we'll just make a new string out of this. So we'll put that stuff here. And then after page, we will add this part and then end the string. Okay, let's format this. Come on, prettier. How does this work? Is that how it works? It looks awful. Const next. So I'm doing this only for formatting reasons, but if the auto formatter makes it look very, very ugly, perhaps the code is ugly. Next page number. Let's just take this here. Add it there, the next page number, and then input here. Let's just put the next page number. So let's just check this out. Will this work if we run this in the console? Run it again. Like that. What's the next URL? Not a number. That was not what I wanted. Undefined. Page equals. Oh, I forgot to add the parents here. The capture group. Now it should work. So if I add the capture group here, then there will be that number 9. With the capture group. So next URL. Yeah, it worked. We inputted number 9 and then we got number 10, which is the next one. Awesome, it works. Let's recap what we did. We realized that here there's a system that the pages are incremented. You can just modify the query parameter to go to the whatever page you want. But we can't know the exact number of pages. We know that there are 45 pages here when we go to a very, very high page. But we don't know how that looks. And then we just made a small extraction to just be able to increment the page number here. And we moved things into this extract partner function instead, because we want to be able to call it multiple times. And here we're just awaiting the we await extract partners from the URL we inputted. Let's just enter a really, really high page here and see what happens. Node scraper.js. Okay, Fika break is over, I guess. Oh, I didn't even eat this. Okay, so when we go to page 500, we get an empty array. So it doesn't blow up. And that's because this part is creating an array from these query selectors. But if it doesn't get anything, it doesn't get anything. It's just empty. So now it's the time to actually do the recursion. We validated that we get an empty array. So the final condition is that the array is empty. Because the recursion can go on for infinity and everything gets stuck in a loop, I find it helpful to always start with the end condition. When does the recursion end? Let's just make this here. Scrape the data we want. After we've done that, what is the next page? What is the next URL? That we get here. We are only really interested in this if we want to get another page. So let's just start here. Should we end recursion? So if partners, the partners that we fetched here, let's rename this because we have all the partners here and extract partners. So just to make things clearer when we look at this later on, partners on page. Partners on page. Return partners on page. So if the partners on page dot length is less than 1, or if it's equal to 0, you can write whatever you want. I'm used to writing this. So if the length of the partners is 0, the partners on page is below 1, it's 0. There is no partners on page. No partners on page. Then we're done. We should just return. Then we just return the partners on page. Otherwise, go fetch the next page. So then we can figure out what is the next page. And return. So this is the magic of the recursion now here. For the next page, we want to take the partners we found on this page and concatenate them. So we have all the partners that we found on this page and we want to join them with the partners on the next page. But we don't really know here if there are partners on the next page. But if there isn't, then this will return just an empty array. But if there are 5 partners, so we have 10 partners here, then we want to fetch the next page and we're going to join the arrays. That's the concatenation with the partners on the next page. If there are 5, 100, 10, 0, we don't know. We don't care really. So we just want to concatenate that. And then that's when we call ourself. We call the same function, but with a new URL. So here, let's just add extract partners, but we use the new URL we just created. And because this is asynchronous, we have to await this. Do you get that? Before you think if you get that, let's just see. We can just here console log that terminate recursion on and then the current URL. So this is just to say that this is the end condition. We reach that, we're done. Okay, we didn't call it new URL, we call it next URL. And then we should probably just, I don't know how this works, we can just move this await page close here because we're done up there with the page. And this return doesn't matter because now we have the condition here, that is, either we return here in the if or we return here in the if. And then we should get the part. Let's just skip printing out the partners. I just want to follow these log messages to see what we get. Do we scrape the URL and then we terminate the recursion on the thingy. Run it again, see what happens. scraping page 500. And then we terminate the recursion on page 500. So it works. It works for the end case. We come here, we scrape the URL. It finds nothing. So it goes in here and says, just return the partners. And what happens if we console log the partners? We expect here to get an empty array because we didn't get anything. Yes, empty array. But what if we went to another page? Let's just check page 45 that we know is the final page that has things on it. Page 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has 11 partners on it, if I counted correctly. Let's just go to that page and see that it works and do not go further. Because it should realize that this is the final page. I hope. Yeah. Ah, yeah, okay. So this is the way, this is the logic I built. It's fine. So we scraped number 45, we got partners. And then we went on to number 46 and tried there, but there wasn't nothing there, and then it terminated. And this is good because we can't know. Well, we know if we know how many partners there are on each page, we could terminate this earlier. Like if we know that there are only 20 on each page, we could terminate this earlier. But I think this is fine because then we just try one extra step. Try page 46. It doesn't have anything. It's fine. And then we got everything here. Cool. And if we were to just try this from the start, we'd have to wait for 45 pages. But that's fine. Let's just do that because it's fun. Now we need to save this. Let's run it. Start here, scraping page number 1. Cool. Goes to page number 2. Goes to page number 3. Actually, this is pretty exciting because we haven't seen if the concatenation, if this part actually works, if it's joining the thing. We only know that it's calling itself again, which it should do. But we haven't really checked that the partners on the page get concatenated with the partners on the next page. So we'll see that here when we print it out. If we get more than like 20 partners, we've probably succeeded. Oh, 45 page. Okay, I'll be back soon. Let's just let that run. We're done. I see that we're done. We're done. Whoa, it worked. Check this out. 439 more items. Do they have they fixed it? Is this an H1? Do you think that? Yes, no. Thumbs up, thumbs down. H2. Everything is fine. Everything is just the way it should be. H2. Great. Good job, Google. Does this code make sense? We have the extract partners. Let's just write comments. Extract partners on the page. Recursively check the next page in the URL pattern. Okay. So we open the page. We open a page in the browser. We go to the page. We log out that we're scraping it. Let's just remove that. Scrape the data we want. And then we close the page. Let's just do like this. Here we go. Scrape the data we want. We close the page. And then we just rewrite this. Recursively scrape the next page. And then we remove this. Terminate if no partners exist. Otherwise, go fetch the next page by incrementing page question mark page equal x. So like that. Go fetch the next page. Page x plus 1. And then return it like that. That looks good. And then here we have all the run thingies. And then we log out the partners. And here we can just add a to-do. To-do. Update database with partners. And once we're done, we close the browser. Okay, done! So you can go and check out the link to see the code and try it yourself. Honestly, this is what I'm gonna do now. I'm gonna do the recursion thing here just to check myself to see if I understand this. Brilliant.org/devtips and be one of the first 200 people that sign up and you will get 20% off the annual subscription. Thank you, Brilliant, for supporting this show. DevTips is hosted by me, David and MPJ. He's currently traveling. I think he's in Amsterdam. I don't know. He doesn't respond to my texts, so whatever. These episodes come out every Friday morning, GMT 0800. Do your own math to find out when it's in your time zone. Write comments what you thought about this show or what you want us to do more about. Please subscribe and hit like or dislike to show us what you thought of this episode. And that's it. See you in the next video and go check out brilliant.org. Bye bye bye.